Hello, hi, good morning, and welcome to our chemistry class today. So, really, my children, I feel very happy that you are all preparing for your public exam. So, kindly utilize your time properly, follow the revision schedule. Very, very important. So, don't waste your time. Kindly revise properly. If you have any doubts, you can clarify with me. Okay. So in the last class we studied about very important question, that is about diboron. So diboron is very important topic in this chapter. The structure is very important. If you have any doubts, you can clarify in the class. Next we are going to study about boron trifluoride. So first we'll start with the preparation. So boron trifluoride is prepared by using boron trioxide, that is B2O3. So when boron trioxide is treated with calcium fluoride in the presence of sulfuric acid, you'll get, on heating, you'll get boron trifluoride BF3 with the elimination of calcium sulfate and water molecules. So in your book, instead of BF3, it is printed wrongly as BH3. Afterwards, you can change that. The next preparation, same preparation, next method is BF3 is prepared by using B2O, that is boron trioxide with carbon and fluorine. We'll get BF3 with the elimination of CO, carbon monoxide. Then laboratory preparation. So by this method, you can able to prepare the pure BF3. So by the thermal decomposition of benzene diazonium tetrafluoroborate. See the picture? Benzene diazonium tetrafluoroborate. See the formula. So benzene is nothing but it is mentioned as phenyl group, pH. So phenyl is benzene, C6H5. So phenyl group, then diazo means 2 nitrogen, then borate is boron, then tetrafluoro is F4. So PHN2BF4 is called as benzene diazonium tetrafluoroborate. On heating this, you can able to prepare BF3 with the elimination of fluoride and nitrogen. Next one is the preparation of boron trifluoride. BF3 is used for preparing HBF4. It is nothing but fluoroboric acid and it is used as a catalyst in organic chemistry. Then it is also used as a fluorinating agent. So fluorinating agent is nothing but in which that the fluorine atom is an electron deficient and that act as a reacting species in that reaction, active species in that reaction. Next is the preparation of aluminium chloride. So two methods are mentioned here. So first preparation is when aluminium or aluminium hydroxide is treated with hydrochloric acid, you can able to prepare aluminium chloride. See the picture. See in the first equation aluminium is used and the second equation aluminium hydroxide is used. In both the reaction you are preparing aluminium chloride with the elimination of hydrogen and water molecules respectively. So if you want the hydrated aluminium chloride, you have to evaporate the mixture. So once it is evaporated, once you heat, afterwards that water molecule is converted. Okay, it is evaporated and finally you can able to get the hydrated aluminium chloride. Next process is the McAfee process. So in this process you have to take a mixture of alumina and coke. So alumina is nothing but Al2O3 and coke, it contains carbon. So it is heated in a current of chlorine. You can able to prepare aluminium chloride with the elimination of carbon dioxide. So another preparation is the industrial scale. So industrially it is prepared by treating aluminium with the chlorine and it is heated around 1000 Kelvin. You can able to prepare aluminium chloride. So this question is very important question. Most probably they'll ask in 2 mark or 3 mark question. So next one is the properties of aluminium chloride. So aluminium chloride, it can able to produce hydrochloric acid fumes, HCl fumes, when it is treated with moist air. So actually aqueous solution of aluminium chloride is acidic in nature. So it forms HCl with the elimination of aluminum hydroxide. See the first equation. Then the second one, when aluminum chloride, when it treats with ammonium hydroxide, it can able to form aluminum hydroxide with the elimination of ammonium chloride. Then when it is treated with excess of sodium hydroxide, it can able to produce sodium meta-aluminate, that is NaAlO2, with the elimination of water and sodium chloride. So in this, it behaves as a Lewis acid. Already you studied about the Lewis acid and Lewis base, and it can able to form addition compounds with ammonia, phosphine and carbonyl chloride. Example is AlCl3.6NH3. Next is the uses of aluminum chloride. Anhydrous aluminum chloride is used as a catalyst in Friedel-Crafts reaction. So what does it mean by anhydrous? Without any water molecules. So when it is evaporated, all the water molecules will move away, and you'll get aluminum chloride in the form of a powder. It is used in the manufacture of petrol by cracking the mineral oils. It is also used as a catalyst in the manufacture of dyes, drugs and perfumes. So these are all the uses of aluminum chloride. Next heading is the alum. So alum, that name is given for the double salts. So it contains two salts. So already you know, a salt means it contains a basic radical and acid radical. That is, it contains one cation and anion. So when two salts are mixed together, then it is named as alum. Some of the examples are given. The first one is the potash alum. See the picture, that contains potassium sulfate and aluminum sulfate with 24 water molecules. Then sodium alum, sodium sulfate, aluminum sulfate with water molecules. Then ammonium alum, it contains ammonium sulfate and aluminum sulfate with water molecules. Then chrome alum, it contains potassium sulfate and chromium sulfate with 24 water molecules. So generally alums are more soluble in hot water than in cold water. So and in solutions, they exhibit the properties of the constituent ion. So once you mix it with water, that can able to separate into respective ions. And depending on that ions, it will show the properties. Next one is the preparation of potash alum. So already you know the formula of potash alum. It is prepared by using alum stone. The formula of alum stone is K2SO4 Al2SO4 thrice 4AlOH thrice. It is treated with excess of sulfuric acid. You'll get potassium sulfate and aluminum sulfate. So to this aluminum sulfate, you have to add calculated quality of potassium sulfate. So it just recrystallized and it forms potash alum K2SO4 Al2SO4 thrice .24H2O. So for further purification, you have to recrystallize. So this is the preparation of potash alum. Next one is the properties of potash alum. So when you heat that potash alum up to 365 Kelvin, it starts melting. Then after 475 Kelvin, it loses all the water molecules and it becomes swells up. So what is meant by swells up? Swollen and ஒரு மாதிரி உப்புன மாதிரி வீங்கின மாதிரி ஆயிடுது. So the swollen mass is known as the burnt alum. This is very important question. Sometimes they may ask in 2 mark. So what is burnt alum? So burnt alum is nothing but when potash alum is heated up to 475 Kelvin, it loses water molecules and becomes swells up, and that swollen mass is known as the burnt alum. So on red hot heating, it decomposes into potassium sulfate, alumina and sulfur trioxide. Okay, the easiest example for you is like idli maavu. இப்போ இட்லி இருக்கு இல்லையா, இட் ஹாஸ் தண்ணியாக இருக்கும். ஸோ நம்ம ஆன் ஹீட்டிங் என்ன ஆகுது, அப்படியே அதில் இருக்க வாட்டர்ஸ் எல்லாம் என்ன ஆகுது, எவாப்ரேட் ஆகி அப்படியே ஒரு சாஃப்டாக ஒரு ஸ்பாஞ்சியான ஒரு ஸ்வெல்லன். நம்ம நார்மலாக மாவு ஊற்றும் போது ஃப்ளாட்டாக இருக்கும். ஆனால் அது அந்த பாயில் பண்ண வாட்டர் மாலிகூல்ஸை லாஸ் பண்ணும்போது எப்படி ஆகிடும், ஒரு மாதிரி நல்லா உப்புன மாதிரி ஆயிரும். தட் இஸ் கால்ட் அஸ் தி swollen mass. அதே மாதிரி தான் இங்கே ஆன் ஹீட் பண்ணும்போது it contains 24 water molecules. ஸோ எல்லா வாட்டர் மாலிகூல்ஸையும் லாஸ் பண்ணிவிட்டு ஒரு swollen mass நமக்கு கிடைக்குது, and that is called as the burnt alum. Next one is the uses of alum. It is used for the purification of water, used for waterproofing in textiles. It is used in dyeing paper, leather tanning industries. It is also used as a styptic agent to arrest bleeding. Okay, because already know. So if you have any cut or wound, after a certain period of time it should stop. If not, if there is a continuous leakage of bleeding, means it leads to death. So to arrest that bleeding, it is used as a styptic agent. So up to this, the properties of 13th group elements has been over. Next we are going to study about the 14th group elements. So already you know carbon belongs to the 14th group, and the elements present in the 14th group is carbon, silicon, germanium, tin and lead. Now let us see the physical properties of group 14. Just see the picture on tabular column is given. So in that, its physical property, everything is mentioned there. That is its physical state, its atomic number, what are the various isotopes of each element, then atomic mass, electronic configuration, atomic radius, density, its melting point and boiling point, everything is mentioned in the form of a tabular column. So just go through once. Isotope is very important, then atomic number as well as electronic configuration is very important. So my dear children, today we will stop up to this. Then the physical properties of 14th group elements will be discussed in the next class. Study well, prepare well for your exam. Thank you. Have a nice day.